Hello friends, welcome to my channel. So in this video, we're going to look at problem 1367, linked list in binary tree. This problem actually provides a good example of practicing recursion. So first, we'll go through the problem statement and also look at the problem constraints, and then we explain the main idea. And finally, we do the coding together. So first, the problem statement. So here we are given a binary tree and a linked list. So we want to return true if all the elements in the linked list, starting from the head, corresponds to some downward path connected in the binary tree. Otherwise, we are going to return false. So in this context, downward path means a path that starts at some node and goes downwards. So here we have 3 examples. In the first example, so we can see 4 to 8 is a path which also forms the corresponding array of the linked list, so we return true. And in the second example, so we have 1, 4, 2, 6, which is the corresponding list, corresponds to the linked list height, and also it's a downward path, but this time it's from the root, so we return true. And in the third example, it's actually the same tree, but the height is has a list is 1, 4, 2, 6, 8. So you can check there's no corresponding downward path, so we return false. So it's also important to notice the constraints. First, the number of nodes in the tree will be at most 2,500, and the number of nodes in the list will be at most 100. In other words, the length is not that long, right? So the node value is in between 1 and 100, right? So with that said, I think we are ready to explain the main idea. So here, we first want to notice that both the linked list and the tree data structure can be defined in a recursive fashion. So this also explains why we can think of recursion given this problem statement. So here we can write a check function to check, so we can see a head and a root to check if a linked list corresponds to a root to child path. Notice that here we want to check if the path, here we specify that the path shall start from the root itself, right? After we have this check function, we could do traversal of the binary tree and call the check function. Once we get a valid check, then we just return true. Afterwards, we are going to return false for sure. So here we have a lot of freedom when we do the traversal. So because the direction is not essential, we can do in-order traversal, pre-order traversal, or post-order traversal. In other words, we can ignore the traversal order, right? So with that said, let's look at the coding part. So as we mentioned, first we are going to write a check function. So given say, let's use make it a method. So we have a linked list and a root. So we want to check if the linked list height corresponds to a root to child path. So this can be very easy to write. So first we check if not height. If not height, no matter root is null or not null, so we return true, right? Then if the height is not null, then we check the root. If not root, so we are going to return false. Otherwise, if both the head and the root are not null, then we can check their value. If head value does not equal to root value, so in this case, tree node value and value, okay. So then in this case, we are going to return false, right? Otherwise, as long as we can match the remaining part of the head, the following nodes in the head, and either in the left subtree or right subtree, we are okay, right? So we are going to return self check head next, or and also root we can check left, or self check, so head next, so we can check the right subtree, right? So this is the check function. So so in other words, if one of those are true, so we are going to return true. Otherwise, we return false. So with this check function at hand, so we can do the traversal. So here, let's do the traversal, right? So we can, let's see, we can use any traversal. So here, I will not emphasize the order. So let's give a stack. So it's a root. So as we mentioned here in the constraint, so the root, the tree is not null, but when we write this function, we need to write those stop condition or base cases. Well, because root is not null, so we can initialize the stack like this. So then we can do the while loop, while stack. So we first get node as pop, right? Then we are going to check if there is a match starting from this node, right? So we are going to check if self check, so head and node. So if it's this case, we are going to return true, right? Otherwise, we continue. So then we can check the left subtree and the right subtree and add to the stack. So if node right, so then we are going to do s append node right. If a node left, so we're going to append node left, right? So because here we can we get first. So let's see, we can return if nothing returned, we need to return false. So here I wrote node right first and then node left first. Actually, you can switch the directions. So if you use right as first, you can see what's the order, right? So for example, you have a tree like this, you have 2 and 3, right? So stack first have 1, then you print 1, and then this pop out. So you get 3, you put 3 here, and then you put 2. Then you do pop, you get 2 and 3. So this corresponding to pre-order traversal, right? But if you put left in front, it will not corresponding to pre-order traversal. So yeah, let's run the test case. Yeah, it passes one test case. Now let's look at the generic case. Yeah, it passes all the cases. Let me put this right here to justify the comment. The order actually is not important for doing the problem here. But if you do traversal or pre-order or post-order, so you need to pay attention to the order here. So let me cut this, put it in front so that it corresponds to pre-order traversal of the binary tree. So with that said, I guess that's it for the current problem. If you are interested in more practices on binary tree traversals, you can look at the specific playlist in my channel. With that said, I guess that's it. Thank you.